All right, so today we're doing almost the exact same thing as what we did yesterday. There are two different ways to measure the angle inside the circle. The first is degrees. That's what we did last time. That's what's most familiar with us. The next one is radians. So radians, again, sounds a lot like the word what? Radius, right? You've got this R length right here. So pretend like it's 5. Okay, pretend like it's radius is 5 or whatever. I don't have a big chance of doing that. Let me get ready. R, pretend like that's 5. This radius right here is also then 5. A radian is the angle. If this length is the same as the radius, so 5 or whatever, then this angle is 1 radian. That's what it's defined as. That does make sense? So it's 1 radian when the arc length, we did that last time, is the same length as the radius. Now we've discovered that if you wrap the radians around the circle, so this is the diameter, right? So that's 1 radian, 2 radians, 3 radians. You get this little kind of hangnail leftover piece. The amount of radians that this little leftover piece is 0.14159. What does that look like? It looks like the decimal part of pi, right? Okay. Now, how many radians then cover this first 3 point what? So what is the measurement from here to here? Pi. Because if you add all of those together, it would be 3 full radians, 0.1415926, which is pi, right? Which means if I have a full rotation around the circle, how many pi's would there be? 2 pi, right? So very underprepared for this lesson. We should be eating pies or something. What do you get? Okay.
I mean, I was last time.
I know, I didn't have celebrate, and I should have because you guys didn't have me any headaches when
I remember on root beer for extra credit math class, and I just found the root beer bought to just put square root beer.
Cute. I think that's a great idea. I think that we should have root beer floats next time, yes?
Yes.
So if I bring the ice cream, will you guys bring the cups and the root beer?
I like it.
No? Can you not have a root beer? Well, you can't either? Is there something else that you guys can have? You know what? Hold on, I've got to pause this. No. I was going to tell you to go somewhere, but I can't record that. I'm gonna get the touring lecture. That's my goal.
So we bring her something.
Okay, so
Wait, you just have root beer? So what if we bought like
what?
ice
Okay, y'all don't need to hear this. Hold on. That never happened. Okay. All right. So, I'm awkward going back to my. Okay, so are we all in agreement that if I were to wrap the angle from here to here, it's just pi? And if I were to go all the way around, it would be 2 pi? Yeah. So if this were a line in degrees, what would I call it? The diameter, we would call it. What degree? The line? 180. So is it okay to say 180 degrees and pi radians are the same? Okay, that means the conversion between radians and degrees and then backwards is 180 over pi or pi over 180. If I wanted to go from one to the other, that's what I would multiply. Raise your hand if you've done some sort of unit conversion in like your physics or chemistry class where you've gone from centimeters to kilometers or from inches to feet. Have you done that? Maybe measurable, we are doing something very similar to that, but not quite as intense. Because if I'm going from like kilometers to inches, I first have to get it down to centimeters, and then I get it. Anyway, so there's a lot of weird that can happen. I'm just doing one little conversion here. But the big thing on that one, if I wanted to go from like 5 miles to something feet, I would need to make sure the units down here was what? Miles. Why would I want to make the point? Why would I want to make sure the miles is on the bottom? Raise your hand if you know. So I can give you guys more points. Andrew. So canceling out the units is a good way for you to remember what goes on top, what goes on bottom, right? Have you done this? I always use mine in a chart, and sometimes the charts get really long. Kind of a similar thing here. I want to go from degrees to radians. Radians have pi in it. So which one of these would I use? I want to make sure the degree on top cancels with the degree on bottom. Which conversion would I use? The first or the second? Because that one has a degree on bottom, this one has a degree on top. If I multiply it, do the degree cancel? Yes. Now I want to leave this final answer, and mine's pretty crafty, which I know we all love. So we have to reduce this as much as we can, and then we're done. What do you notice that goes into 21 and 28? And they're both divisible by 10. We knocked off the 0. We knocked off the degrees because they cancel. Now what goes to 21 and 18? 3 divided by 3. 21 divided by 3 is 7. I put the pi with it. Over 18 divided by 3 is 6. So this is how many radians that are equivalent to 210 degrees. You draw a picture to see if that helps illustrate it. 200, if this is the original starting spot, 210 degrees is somewhere down in here. So that's 210 degrees. That's also 7 pi over 6 radians. So they're the same measurement, just using a different way to measure. Does that sort of make sense? And you don't have to draw the picture as part of your answer, I just want you to see it. So let's do this again. 23, 230. What am I going to multiply that by so that I compare it to degrees? Pi over 180. Good. And I know this is the right conversion because the degrees will cancel. The zeros cancel. Does anything go into 23 and 1? I'm struggling. Start talking about ice cream again and I'll get back to it. What goes into 23 and 18? Well, 10 did, right? Oh, make it turn it around again. Okay, here are really tough. And now we do root up, root spoons. We probably could use a few more beverages. So I'm going to try one more time. If you can do more than one, nobody's going to make fun of you for not trying it at all. If you can do more than one, go to sign up, or if you're like, oh, I'm going to sign up, I'm really try to do that. Monday, I can do this. Okay. All right, nothing goes into the 23 and the 18 once we canceled out the zeros, right? No. So how do I finish this off? 23 pi over 18. Again, the goal for this is to go back from degrees to radians and then radians to degrees. Why don't you try part C? You can do it. There's 3 major learning objectives for today. The first is being able to convert from degrees to radians and radians to degrees. Then I'm back and forth. Okay. The next is to being able to find the arc length, like what we did yesterday, but I'm going to give you radians this time. And then the sector area, but I'm going to give you radians this time. So this first step is new, and then after that, we're basically doing what we did yesterday. All right, and multiply by what? The degrees cancel, the zeros cancel. What goes into 12 and 15?
Oh, I have to.
More than 6. So 12 divided by 6 is 2. Then you always have that pi over 3. Any questions on that? Who got that? Ready to move on? Okay, let's do another, or let's not do another one. Let's go backwards. Oh yeah, we know the fastest one is simplify with this and simplify. So zeros don't automatically cancel, right? So what's something else you could divide? 45 does work, but if you didn't automatically see that, I would start by dividing by 5. 45 divided by 5 is 9. 180 divided by 5 is 36. And once I get to this step, it's easier to see that 9 goes into both of them. So I divide the top and the bottom by 9 and call it 1/4. Or you can call it pi over 4. Alright, so now we're going to go backwards. When I was going from degrees to radians, I did pi over 180. What do you suppose I will multiply by here so that the pi's cancel? 180 over pi. If there's a pi on top, there needs to be a pi on bottom. Because when there is, you cancel the pi. And now this is all calculator work. On your calculator, 7 times 180 divides 12 equals what? Everybody on the calculator. Raise your hand when you got it. 7 times 180 divides 12. I'm going to call on one of you. 7 times 180 divides 12. Brady. 105. 105. Ever do that 105? So you give yourself a point. Brady, you can have 2.
I like the point.
Woo! What happened last quarter with the tickets? However many tickets you had, I gave you that many times to start on your homework grade. And then I divided it by 10, so I'm taking 65 tickets, and we just take extra test questions on some people. So that's how I did it. It averaged to be about a 2% boost for most people. So, some people, the people that isn't going to do anything, because some people are don't do it. Okay, what about the next one? Multiply. And then what? Right, cancel. Multiply out. Every time you got it. Let's go, Aaron. 273. Did we all get 220? Good. We got 220. Give yourself a point. And you have 2. Last one for a T. So that one's all done.
Some of my classes have had treats, I guess. Yeah, that's what I was thinking of. My third period had pizza lunch because it was the fundraiser. So I went and bought pizza from Little Caesars. And rather than them spending $5 for the box of pizza, they spent $10 for the box of pizza, and all of the extra money went towards the fundraiser. So that's the way that we raised money. Because we came in second place. Last year I came in third place. This year I came in second place, so if the trend continues, then next year I win, which is all that really matters.
Okay, this one, multiply it by pi over 180. Nope. 180 over pi. What do we get? 15 degrees. Every time you got 15 points. Good. And take 5 minutes.
10 minutes? 5. Take 5 minutes. Record. Now our goal is to do the same thing that we did last time. The only difference is we are given a measurement in radians instead of degrees. Our formula is the same. Sorry, what? Pretty much.
Don't forget the formula. You have to find the fraction and then multiply it by 2 pi r. Or if you're talking about the area of a sector, so pizza, what is it? You find the fraction and then do what? Multiply by. Okay. Alright, those are our two formulas from last time. This is note 9.2. After today, we are more than halfway done with our unit. Okay, so when you're trying to find the length of this sector, I start with taking the 7 pi over 6 and multiplying it by 2. I start with taking the 7 pi over 6 and multiplying by what? 180 over pi. And I know it's 180 over pi because I want the what? I want the pi's to cancel. Good. Multiply by 180 over pi. Do you have to reduce this like it was a fraction, or can you just plug it into your calculator? Just plug it in. So everybody please change that to degrees. Yes. Oh, you knew it. Oh. Hold on 1 second, everybody plug it in.
Did y'all get 210?
You got 210, give yourself a point. Or 15, give me 2. Second.
Now I'm going to take that 210 and do what with it? Eat it. No.
We need to find a fraction, right? So the first step is changing it to degrees. Second step, find the fraction. Do I want to leave this? Do I have to do the exact? Exact form only, we don't care about the decimal. So I do need to simplify the fraction. The zeros cancel. What goes into 21 and 36? 3. So that's my first fraction. Now what do I do with my first fraction? Oh, I guess I need to find the circumference first, right? Circumference equals 2 pi times 11. So that's 22 pi. We don't need this anymore, right? So reduce it. I take this guy, I multiply them together. Then we reduce it. What goes into 22 and 12? 2. Make that an 11, make that a 6. Anything else? Okay, so then I multiply the top, what do I get? Almost identical to yesterday. What's the difference? One more step. Like one more step, we'll have to change it. Get it on because I didn't do it. I'm almost positive that it will not work for Eric. But I think it does work because of the circumference formula and this conversion and those Let's try this one and see if it works. Because if it does, then let's do this move direct on a little bit easier. Probably not a problem. So this one, Mom told me to learn new math and I never thought about it that way before. This one, change the 2 pi thirds into degrees. What do you get? Multiply it by 180 over pi. And I'm trying to prove that at the same time I'm talking to you. What do we get here? 360 over 3, which would be 120. Okay. And then if we take the 120, have you already multiplied these two together, Brooklyn? Look at your way. You still probably need with your way. So 120 over what? Ooh, that's 3. Duh. Yes, it should have worked that way. There's a formula that I did earlier in a few minutes. Yeah. Good job. I can't prove it right now. Cross my leg. Yes, it works. Hey, do we multiply this out? Or divide this out? We get what? Let me finish showing you this way, and then I'll show you Brooklyn's method. You now have your own name. Brooklyn's method. That's what we'll call it for the rest of the school year. What goes into 12 and 3 and 36? Divide by 12. And we get 1/3. I lied. I don't even want to show this to you. Can I show you Brooklyn's method? Okay. She said, this is the formula I did my other students, and this only works for arclight, and this only works when it's in radians. If it's not in radians, you got to do the long ways before. But when it is in radians, I can take the radius, which is 18, multiply it by that central angle, S stands for arclight. And that's what you get. So, I don't know if you want to use S. What happened here is she noticed that I took that 11 and multiplied it by this, and I got 77 pi over 6. Is that what we got? And then it said, is that a coincidence? And now it was like, yes, it's not here normally. And then I thought about it and said, well, maybe it's not a coincidence. So on this one, is there anything that simplifies? So the 8 and the 18 and the 3 becomes a what? 6 and a 1. So what's my final answer? 6 times 2, 12 pi. Everybody say thank you, Brooklyn. Okay. Very good. Let's do another one, part C. Do we have a central angle in radians? It has to be radians. We have a radius. So our arc plane, I don't know how to abbreviate that, equals the radius times what? 13 pi over 12. Is anything simplified here? Divide this by what? 3, we get 4. Divide this by 3, we get 5. What's 5 times 13? 65 pi over 4. In fact, I might, when I'm doing this, convert all of my degrees to radians, and then just do it this way. I think it's easier. Maybe I do it that way. Done. So using Brooklyn's method, try part D. Well, there's a Pythagorean theorem. Pythagoras is known forever from his theorem. I mean, technically, I guess, isn't hers, but she's the one that came up with it in this class. It's now Brooklyn's theorem. Should be fast, right? So we do what? Arc length equals what? 11 multiplied. I'm a little bit concerned that this is so quick that you may forget it, so I'm not going to do the whole good until you get it skipped in thing. I would like you to do all of these in this section right now. If I use units, there would be a meters here, right? There would be a yards here. There would be a centimeters up here. Okay, I'm pausing you up for a minute. See as many of them done as you can. Thank you, Brooklyn. Together. But I've written all over my paper, right? Okay. So we're going to have to screw this in somehow.
how, I don't know if you want to write on a separate sheet of paper, I'm just going to do this. Let's talk about sector area now. How many sector area problems do you have on the homework?
4.
That's it? Yeah. Okay, so I'm not doing that. Here, so. Okay, I'm going to do the first one using the n over 360 formula. Do we already have what this central angle is in degrees? So we go through the word, change it to what? Let me guess. 210? Okay. We're going to change it to 210 degrees. We're going to find a fraction, which we've already done, right? Which is what? 712. And this time we're going to multiply it by what? Pi divided by squared, which is 121 pi. Is there anything that will cancel between the 12 and the 121? 121 is just 11, so no. So let me rewrite this. How do you finish it off? 7 over 12 times 121 pi. We get what? What's 7 times 121? So hold on. I don't want the approximate, I want the exact. So 7 times 121 again? 847, so this is 847 pi over 12. We expect kind of ugly answers with these because area is ugly. It's bigger. 847 pi over 12 centimeters squared, right? The units on this one would be, would be centimeters squared because area is a two-dimensional measurement. Okay, now let's use the other formula that I don't have to make the conversion. I want to do both of them, so this column will be degrees, this column will be radians, and you can choose which way you'd like to do it. Is that fair, or is that confusing? Okay, so let's just do it this way. So area, the formula area equals 1/2, because the 180 is half of the 360. Not pi, what is it? R squared theta. So 1/2, what's R in this case? 18. I'm going to say 18 times 18. And what's theta? 2 pi over 3. The reason I broke it out so it's 18 times 18, I hope that helps me simplify things. Looking at this first 18 and the 2, do they have anything in common? A 2? So divide that by 1 or 2, you get 1. Divide that by 2, you get 9. Looking at either the 9 or the 18, it doesn't matter. Do either one of those have something with a 3? Yes. Okay, so do you get to take 3 out of both of them? No, just one of them. So pick one. Look at the 6. Is everything canceled but can't cancel? So 1 times 9 times 6 times 2. 108?
Yeah.
Okay, 108 pi, we're done. We don't need the pi in the formula anymore because the pi is in the radians, right? Let's do another one like that, and then the last one you decide and tell me what you want to do. So let's do it again. Area equals 1/2. What's R? 11 times 11. I spread it out so it's easier to cancel things. What's theta? 5 pi over 4. Look at the numerator and the denominator. Does anything cancel? No, so you just multiply straight across. 11 times 11 times 5. 605. So 11 times 11 times 5 is 605 pi over what? 8. Feel good about it. Part C, how would you like to do it? Option 1. We do a blind vote. Everybody close your eyes. Option 1 is changing it to degrees first. Option 2 is just using the radian formula. All in favor of option 1, changing it to degrees first. All in favor of option 2, using the Radians formula. Okay, blind vote over. On one, not option 1, but one method 1. However, we've done 2 of these already. If you feel good about those, are you good to carry forward and keep going?
I just want to do one more where we change it just to make sure that both options get everybody's an option to use it. So this one, if I want to change it to degrees, 13 pi over 12, how do I change that to degrees? Multiply it by what? Let me do the pi. So the pi's cancel. Then 13, oh, is anything canceled from here? Is it 12 divided by 20 times 15? This becomes a 15, and 13 times 15 is what? So this central angle right here is 195 degrees. So then if I want to find the area, we take 195, divide it by what? 360. Multiply that, or you want to multiply now. How do you reduce that? Divide the top and the bottom by what? 5. I just probably write it there. And then you get 69 up. I would be wrong. Divide that by 5. You get 72. Okay. If those are both divisible by, you get 13 over 24. So that's my fraction. I'm going to take that 13 over 24, and I'm going to multiply it by pi r squared. I spread out that r squared just like I did here so that it's easier to cancel things. Then I can go to 24 and 15. Oh, wow. 3. Divide this by 3, you get 8. Divide this by 3, you get 5. Anything else? You know, so what's 13 times 5 times 15? I feel like I lost it. What is it? And then 35 pi. 8. Woo!
Woo! Thanks for watching.